Hello everyone, today we're going to solve the LeetCode problem number 2873, maximum value of an ordered triplet 1. It is an easy problem, but it has a catch that we will discuss later. So, from description, we are given a zero-indexed integer array nums, and we should return the maximum value over all triplets of indexes I, j, k, such as I less than j and j less than k. If all such triplets have a negative value, we will return 0. The value of triplets of indexes I, j, k is equal to nums minus nums I minus nums j, and we will multiply this by nums k. So it's better always think about what will be the right solution from perspective of input and output. Because when we check this example, we can see that we choose 0, the first element here, we choose second, which is the third element here, and we choose the 4, which is the last element, 5. And we clearly see that we choose the biggest number for I, the smallest number for j, and the second biggest number for k. And its goals align with maximum value. And from here we can see that we can approach this from greedy. If we move, for example, to the description, we understand that I shouldn't be less than j and j less than k. We want to have the biggest I, the biggest k, and the smaller j. Also, from hint, we can get understanding that we can use 3 nested loops to find all triplets. It will be very easy to do because we can just brute force and check every possible combinations, but it will have a time complexity of n squared 3, which not satisfied for us, and we kind of try to approach it in more easy way. So the best way will be for us to start with algorithm, which will be greedy, and we will use it together with single pass. The idea of single pass here that we wouldn't use extra space. We just go for space complexity of big O n, big O1. And time complexity will be big O of n because we will only pass an array one time. So we will create 3 variables. We'll start with result, which will be equal to 0. Then we will make difference because we need to calculate the difference between nums and I, nums and j, and multiply it by k, nums of k. So we can pre-calculate firstly what is this difference will be before multiplying it. And lastly, we'll need the left side represented. Then we will run one for loop where we use const of I of nums, and here we will start with calculating rest, which will be equal math max. We will use max function. We'll use rest and kindly copy this statement, but instead of nums index I and nums index j, we will use our difference, and for multiplication we will use I as our k. Then we need to start calculating our difference. So we also use max, and here we will use left side and minus it from k. Then we need to know left side, which also should be the max of what possible, and it will be of a. So we will scroll until it's possible to make the biggest left side. And then we will return result. In this way, we will have time complexity of big O of n and space complexity big O of 1, because we have constant. We don't use extra space to create another array, or for example 3 arrays. Right, now let's check our code. Good, it accepted, and submit. And it's pretty good with 83% of runtime and memory of 81. Yeah, slightly less than memory, but it's good. So what we can take from this easy problem, that it's most important to look on input and output to understand what exactly the solution of the problem is. This provides more explanation than the explanation itself. So thank you for your attention and have a nice day.